Okay, there's 3 other trig ratios or trig functions, but generally they're really not that useful, so you don't really see them that often. So essentially I only remember them as reciprocal sets. So we have sine, cosine, and tangent. Then we have cosecant, secant, and cotangent. And how I remember is that sine starts with S, cosecant starts with C, so you have to match S to C. Cosine starts with C, secant starts with S. Okay, what I don't understand is why I don't see everybody's notes out in front of them right now. Okay, all right, so, and they are defined as reciprocal functions. So this is essentially 1 over sine, which is saying flip it upside down. Okay, so if sine of my angle was opposite over hypotenuse, then if I flip that upside down, what is my cosecant? So hypotenuse over the opposite side, okay? If my sine value happens to be 5 over 9, so if I found the sine value, then how would I find the cosecant value? What's the cosecant then? Okay, essentially reciprocal. So take the same numbers except doing the opposite way, because there's 6 different possibilities of organization. Okay. So on this triangle, here's my reference angle. The missing side happens to be 10. Okay. That's one of the sets that I know. 6 squared plus 8 squared is 36 plus 64 equals 10 squared, because that's 100. Okay. If I'm looking at the hypotenuse, that's the side opposite this 90. So there's my hypotenuse. Notice I mark my angle like this because essentially the side I do not mark is always the opposite side. Okay, so my opposite side is going to be 8. My adjacent side is 6. If I can't see how the relationship works, then one of the things you do is just mark your sides, like figure out, take a second, figure out what is what, right? Which side is opposite, which side is adjacent, which side is your hypotenuse. I start with sine. For me, I always look at sine first because sine's easier for me. So sine would be, what's the opposite side, guys? What's the actual value? I see an 8. What's the hypotenuse value? 10. So that equals 4/5. That means cosecant is actually what? 5/4. So my personal process is I actually don't ever find the reciprocal set, which cosecant, secant, cotangent directly. I usually look for the original 3 and then just flip them, okay? Essentially because if you're using calculators, all right, calculators, no calculator out there has the reciprocal functions. All calculators only have sine, cosine, and tangent buttons because they didn't want to add 6 buttons, okay? So it's just a little easier if you're dealing with that way. All right, so cosine, the next one's cosine. Cosine of theta is defined as, well, I'm looking for adjacent, opposite, hypotenuse, which 2 of those is for adjacent over what? That means secant would be, what would secant be then? Okay, if I happen to know that cosine value is 7 over 13, Stitcher, what would secant be? Okay. Second problem here, I have a right triangle. There's my reference angle there. That side, the missing side happens to be 3. Here's my hypotenuse. Here's my adjacent. So secant of theta is going to be, finding it directly, is going to be 5 over 3. The hypotenuse value over the adjacent value of the sides. Picking two of the sides, making them a fraction. Okay, so that's finding it directly using the direct ratio. Okay. Last one here. Cotangent is 1 over tangent. If I could write a J, that would be good. Adjacent over opposite. All right, if I happen to know that tangent is 19 over 15, thanks, Macy. All right, I'm not going to do this one because it has a radical and I don't want to. All right, does everyone understand the basic idea of the reciprocal sets? Same numbers, just upside down, okay? Joe. That we just found it. It's finding, basically you're saying I'm putting in an angle, so I'm picking some angle out of my right triangle, and I'm picking the two sides that are this particular defined as this particular one, and then I make it into a fraction. So it's basically generating a fraction from two of the sides. And it's just which two of the sides and which way do I write them. And then basically when I'm saying sine, cosine, tangent, I'm saying I have defined this to be these two. So instead of saying, oh, go find opposite and hypotenuse and make them a fraction, I'm saying sine, and that means the same thing. All right, so if I'm finding all my trig ratios, okay, if I find all my trig ratios, here is my angle. All right, I would like you guys to find your 6 trig ratios. Do we feel like we can do that and then go over the answers? Or do we feel like we need to just walk through it? We want to walk through it. Okay, so there's my angle. All right, I'm using theta as the reference angle. I've marked it. I should hopefully be able to tell that 17 is my diagonal side. 17 is basically, there's my corner, right? So your hypotenuse is always not connected. It's not, the corner is the corner and the hypotenuse is the diagonal. So you got your corners, your two sides on the corner. The third side is the hypotenuse always. Okay, which side would be adjacent then? Which side is next to that angle measure? Okay, so there is my adjacent side, and that leaves 8 as my side that is not connected to the angle, so that side over there is the opposite side. If you want to use a single letter, that's fine. Okay, what is sine? Sine is opposite over hypotenuse. Since I know that sine is 8 over 17, okay, I know cosine. So if I know it's 15 over 17, it's the reciprocal of cosine. So flip it upside down. What are you going to tell me? Secant is, here's cosine, right? Here's secant. So what is secant? There you go. What is tangent then? Okay, what two sides is tangent? Okay, there's 8 over 15. So then what's cotangent? Okay, if you can find 3 of them, you know that you don't have to figure out the other 3, okay? If you know the first 3, just flip them over for the second 3. Okay, these are considered, I consider these the master. These are the main ones. So these are the ones I work with personally because these are the ones I see on my calculator. These are the ones you always calculate with. If you go further in math, these are the ones you actually do math on. Okay, so the other ones are like you kind of use them a little bit, but not a lot. So I kind of don't use them that much. I use the main 3. they're just easier for me. Okay, so B is a little more challenging because you've got a radical in there, but it pretty much works the same way. So I'd like you guys to try that one, and we'll go over the answers. Okay. All right, here is my angle. What is my sine? What is cosecant then?
3 over 1?
3 over 1 or 3, okay? Did you get the cosine value? What did you get? And if you did you reduce that? Okay, so if I reduce to root 10 over 6, what do I end up with? Square root of 10 over 3. And then when I flip that over, I get, for secant, I get 3 over square root of 10. That's essentially the answer, but one of the rules of simplified fractions is if I'm trying to write it as a simplified fraction, I cannot have radicals in the denominator. Okay? All right. So what I want to do to remove the radical out of the denominator, multiply by something that equals 1. And what I want to do is pick the number that makes that a perfect square, because squaring the square root removes the square root. So square root of 10 times square root of 10 is just 10. And on the top, then I have 3 root 10. Very important thing here. Square root of 10 and 10 are not the same number, so you cannot reduce them. This is done, okay? That radical is like a lockdown. You can also think about it this way. If I actually could cancel out 10 and 10, essentially what I'd be left with is 3 in a radical sign, which makes no sense, okay? So you can't do that, all right? So 3 root 10 over 10 is actually your simplified answer there. Get the tangent. Okay, and that turns into reduced. Okay, 2 over 2 is, so 1 over root 10. And I would essentially choose this version to flip because 1 over root 10 flipped becomes just root 10. Okay, so there's my reciprocal. Because when I multiply this by the, because I do need to simplify that, rationalize that, I get 10 over, no wait, that's not what I get. I get square root of 10 over 10. Okay? So this one's a little more challenging because of the fact that there's 2 things. One, they have a common factor. Essentially, this is a larger triangle. It's a triangle that was expanded by a factor of 2. So all your fractions end up as the same numbers, but they're all bigger by 2, so then you have to reduce that out. So that's the first thing. And then the second thing that makes it more difficult is you have a radical running around in the problem, which means you then have to pay attention to the fact that you don't want radicals in your denominator. Are we all right with finding the trig ratios if you have given information? Okay, on the next thing, we are going to be using a calculator to find values, okay? On the regular graphing calculator, on this calculator, and I'm not sure, it depends on what your calculator is, but on this calculator, if you hit the mode button, you get this big long list of stuff you can choose from. About the 3rd row down, it says radians and degrees. Okay, there's actually 3 different units for angle measures, right? Just like we have units for distance. We have inches, we have feet, we have miles, we have kilometers, we have centimeters. There's all these different units. So if I say, 1,000 inches, I wouldn't say 1,000 feet and expect those to be the same. So as I change my numbers, okay, I changed my unit, so I could say 12 feet is exactly equivalent to 120 inches, but the numbers 12 and 120 aren't the same. So angles have the same kind of idea. So you want to make sure you're actually in degree measures. So because basically when we do triangles in space, the standard angle measure unit is degrees. To check you're in degrees, your check for it being in degrees, do sine of 30, and that should equal 0.5. So if you're in the right unit, then when you do sine of 30 degrees, it should come back to essentially 1/2. So that's an easy way to check, okay? You could also do tangent of 45. Tangent of 45 should come back to 1. So that's a check to make sure you do actually have degree mode. Okay, when you're doing these on a calculator, again, these are irrational number sets because these particular triangles that they're doing where you have a 65-degree angle have radicals in the sides. That means they are irrational answers. So if I do cosine, you guys should verify that you're getting the same answers I am. So if I do cosine of 65 degrees, I'm getting 0.4226. Oh no, if I'm doing cosecant, my calculator only has sine, cosine, and tangent as actual options. So how can I calculate cosecant if it's not on there, Jacob? Okay, so I could do essentially, if I want to put it in directly, 1 over sine of 28 degrees, because so cosecant is the reciprocal function. This is honestly the real reason I only use sine, cosine, tangent, because if you ever do calculations, you can't use cosecant anyway. You have to do it in terms of sine. So 1 divided by sine 28, 2.13. Okay, please make sure that you're able to generate those same values. And then this can be really useful here, your check values, to make sure that you're actually, either one doesn't matter, but make sure before you start doing a bunch of calculations that your calculator is set correctly to give you the right answer. All right, so because the next thing we want to do is actually calculate stuff, okay? So we want to be able to use our calculator. This is essentially just triangle definitions. Okay, when we are randomly using triangles, and the rest of the triangles in here and in 6.2, you'll start seeing that triangles are labeled, okay? And essentially they're labeled A, B, C. Okay, and then your sides. So generally the angles are capitalized and the sides are lowercase. All right? If I mark angle A, side A is the one I did not touch. So side angle A and side A are opposite to each other. Side A is opposite angle A, side B opposite angle B, side C opposite angle C. The reason why this is because essentially it works like an angle measure does this. So basically if between my fingers is the side and the angle is where my hands are touching, okay, as my hands get farther apart, my fingers get farther apart. Larger angle, opposite larger side. Smaller angle, opposite smaller side. So you're kind of looking at it as angles as like hinges, like a door or something, okay? And that's why they're set up opposite, because then I can say like the biggest angle has to be opposite the biggest side. The smallest angle has to be opposite the smallest side. Small angle means small side. Large angle means large side. Okay? if I happen to have a right triangle, then usually, not always, but usually C is the right angle, side C is the hypotenuse. Okay, so generally they make side C, and that's honestly, that's also the other place they get the Pythagorean theorem, a squared plus b squared equals c squared. The two shorter sides equals the square of the longer side. Okay, it's coming from your standard triangle definition. All right, and basically we always label our triangles this way so that when we're out there doing problems, it's like this is our standard labeling. So then I can build a formula around that, or I can say, hey, we're using triangles, and you're like, aha, I know that the angles are opposite the sides. I just use the same letters, capital, lowercase, okay? That's essentially just definition. Any questions on that? Hopefully fairly straightforward. Okay. So if I want to use, we found out in the last class that A is actually wrong. A is not actually a right triangle. This is really horrible. I'm going to turn it into a right triangle. 15, 17. Okay. Otherwise, it's those numbers don't actually solve the Pythagorean theorem, so it's labeled as a right triangle. We're supposed to be using it as a right triangle, but actually A is not a right triangle, sadly. So we need to fix that. All right. So what am I looking for? In the first one, I'm looking for theta. Okay. I have all three sides, so I have no limitation on what I want to find. Okay. So Mackenzie Beck, what do you want to use? Sine, cosine, or tangent? Okay. If I am using tangent of my angle, what is tangent of that angle? What two numbers am I going to put in there for the tangent? 6 over, why not 17? That's the hypotenuse. There is my right angle, so h for my hypotenuse. Okay, 6 over 15. Okay, that is the tangent value. Tangent of this angle gives me a value of 6 over 15. Is that the actual angle measure? No. Okay, so if I want the angle measure, if I actually want to know what the angle is equal to, what do I have to get rid of? What's extra over here? So I need to remove tangent. Okay? So I essentially need to use the inverse tangent. Okay? Where do you think the inverse tangent button is on your calculators? Yeah. So inverse trig. Okay? If I have tangent, then the inverse is tangent with the little minus 1. So that little minus 1 basically says, hey, I'm not going to build a whole new equation. I'm not going to build a whole new function for the inverse tangent. I'm just saying, okay, this is tangent, but the minus 1 tells you it's the opposite. So tangent is I put in an angle and I get out a side, I get out a fraction. Okay, inverse tangent is put in a fraction and get out an angle measure. So what I do is I basically say, okay, I'm inversing both sides of my equation. So that goes away. That leaves me with my angle. And then over here, what I have is the inverse tangent of my value. And what is that? Inverse tangent is 6 over 15. 21.801 degrees. Okay. By the way, that should also work for if it is an actual right triangle. Okay, trig ratios are a little tricky because of the fact that they a lot of times have radical values, but it should be really close if I did theta. Let's do a different one. Let's do inverse. Do you want to do inverse sine or inverse cosine, guys? Any preferences? Sine or cosine? Let's do sine. Inverse sine. Sine would be 6 over 17, opposite over hypotenuse. Okay, please note that they're not quite exactly the same value because of the fact that you've got radical sets and it's sort of dividing them out. Okay. Your inverse trig values are always kind of basically it's running off a set of tables in the calculator that's built. All right, so it's pretty much a lookup chart. That's what it is. All right, so anyway, that's how it works. Okay. If you want the angle measure, you need to apply the inverse, and that's the little, so basically the inverse says, I want an angle for my answer, okay? The actual trig says, I want you to give me a fraction for my answer, all right? On this one, there's my angle. X is what I'm looking for. So what do I have? I have an angle measure, and based on that angle, X is which side? Opposite, adjacent, hypotenuse. Okay, 20 is what side? Opposite or adjacent? Okay, notice in this one I can't just pick anything I want. Can't just pick any number because of the fact that, well, I don't have all three values, right? So essentially, if I've labeled my diagram, I have an angle measure, I have an opposite side, I have the hypotenuse. What trig ratio should I use for this? Which trig ratio uses opposite and hypotenuse? Sine. So a setup of this problem would be saying, okay, so sine, what do I put inside sine? What number goes in there? What's the angle measure, guys? So sine of 70, because I put in an angle measure, equals what? 20 opposite over x. Okay? By the way, if it was the other way around, it'd be really easy. I just multiply 20 by both sides. This one's a little more challenging because the x happens to be in the denominator. Okay, so now I need to do a bunch of solving. All right. I need to move x from essentially the right side to the left side because it shouldn't be on the bottom anyway. How do I move it off of the bottom? So I do what? I multiply it. Yes, I times it. So what am I multiplying both sides by? X over x is 1. So right now I'm left with x sine of 70 equals 20. Okay, I'm trying to get x by itself. What's the next thing I need to get out of there? What's next to x that I don't want next to x? Okay, yes, and be careful because that is all together, okay? You can't just pull that. You cannot just divide out 70. It's sine of 70. Sine is like a plus sign. So if you divide out 70, it's like you're left sine by itself, and now it has nowhere to go, okay? That has to be together. If you need to add parentheses around that, that is its own thing. So I divide by that. That's my actual mathematical statement. Okay, so there's my work. There's my math statement of my answer. And what is my actual answer? Say that one more time. Do we agree or disagree? Agree. Okay, good. All right. Do we feel like we need to pause here for a minute? Or are we ready to move on? Okay, so the last thing is, if we have basically to find a full triangle, when it's saying solve, what it means is a triangle has 6 pieces, okay? It has 3 sides and 3 angles, okay? If you have at least 3 of those pieces, you can find, you have to have half of it. If you don't have at least half, you won't be able to finish it because you need at least 3 pieces, okay? And you need at least one side. If you have all you have is angles, you could have like a scale model, or you could have like a giant thing. So you have to have at least one side to tell you how big it is. All right. So I need at least 3 pieces. What I know for this triangle right now, the 3 pieces I know, labeling my sides A, B, C. Okay, angle B is 25 degrees. Angle C is 90 degrees. Side B is 1.6. This is my given angle. Okay. Easiest thing to, what's the very easiest thing to find in this triangle?
180 minus 25 and 90.
So this is my work. This is what I would want to see. And then I plug that in and I get what?
65.
So 65 degrees for the measured angle A. Okay, there I am. All right, so now you really have your choice. What side do you guys want to find first? Do you want to find side A or side C? Okay, for finding side A, I'm going to use B as my reference angle. I've already marked it. So if I use A as my side, that side is my adjacent side, and the side I know is my opposite side. So those are the 2 sides that I have, the opposite to that angle and the adjacent to that angle. Yeah. Yes. So I'm going to do tangent. What's my input value? Tangent of 25 equals 1.6, my opposite over my A. Okay. So now I'm going to have to kind of do the same work that I did on the last problem, because A, you want to set it up first and then decide what to do next. In this case, A is on the denominator again. So I'm going to do the same kind of process. Multiply both sides by A. And A tangent of 25 equals 1.6. Divide by the tangent of 25, because that's gone, that's 1. So then A equals, what does it equal? 1.6 divided by tangent of whatever, 25. 3.43. 3.4312. All right. So now I need to find side C. I have 2 choices. Choice 1, use a trig ratio again, either sine or cosine, okay? Choice 2, since I now have 2 sides, I know 2 of the sides of this triangle. What if I know 2 of the sides of the triangle and it's a right triangle, what's the theorem I can use? Pythagorean theorem, okay? So I think I'm just going to go forth with the Pythagorean theorem. So essentially 3.4312 squared plus 1.6 squared, that's A squared plus B squared, equals C squared. 3.4312 squared. So I got 14.333 equals C squared. Am I finished? Is that my final answer?
No.
Okay, be careful. Be careful, because when you use the Pythagorean theorem, everything is squared. That means before you finish, you have to do a square root in there somewhere. 3.786. I'm probably going to take off that 2. Okay, there we go. I have solved the triangle. Solving the triangle just means you found all the pieces. Okay? So basically, this particular section is using your trig ratios and using your inverse, sine, cosine, and tangent to find missing information.